Sir, Nirmal sir.
On the line?
Sir, start பண்ணிடலாமா sir?
Yeah.
Okay sir, thank you sir.
Yeah. Can
Good
I start?
afternoon, yes sir. Good afternoon, I welcome you all for the 5 days faculty development program on modern development in concrete and construction area organized by Department of Civil Engineering, Paavai Engineering College, Namakkal. Today's session will be on the topic studies on the reuse of industrial effluent for construction purposes by our speaker Dr.K.Nirmalkumar. Dr.K. Nirmalkumar obtained his BE Civil Engineering from Bharatiya University in 2000, ME Structural Engineering from Annamalai University in 2001, PhD Civil Engineering from Anna University, Chennai in 2009, MBA from Periyar University in 2013 and MA Psychology from Periyar University in 2018. At present, he is working as professor in Department of Civil Engineering, Kongu Engineering College, Perundurai, Erode. He was recipient of P.K. Das Memorial Best Faculty Award, Senior Category for the year 2009 from Nehru Group of Institutions, Coimbatore. Best Professor of the Year 2015 from Association of Scientists, Developers and Faculties, Pondicherry. Young Scientist Award for the year 2015 to 16 from Venus International Foundation, Chennai. IEA Young Engineers Award for the year 2014 to 15 from Institution of Engineers, Kolkata. He had published 180 technical applications in various reputed international and national journals and conferences in diversified areas and published a chapter in the textbook Advances in Civil Engineering Volume 3. He is currently supervising 11 PhD research scholars. At present, he is a reviewer of 26 international and national journals, which includes 2 premier Elsevier journals, where a reviewer of 3 national conferences, 5 international conferences, and 6 textbooks. He had completed 2 research and development projects funded by UCG and AECT to a total turnover of Rs 13.80 lakhs. At present, he is the principal investigator of a research and development project funded by the Department of Science and Technology, New Delhi, under fast track scheme to a total turnover of Rs 3.24 lakhs. He has played a pivotal role of as expert member of PhD Oral Examination Board of Anna University, Chennai, Indian Examiner for PhD Waiver of Examination of MGR Deemed University, Chennai, External Examiner of PhD of Visvesvaraya Technical University, Karnataka, editor of 3 journals. He had worked in about 164 committees at various capacities in his institute. He had associated in several testing and consultancy activities in the field of surveying and concrete to a turn of 11.59 lakhs. He is life member of ISTE, ICA, IGS, ISDS, International Association of Engineers, ISQEM. He is fellow in Institution of Engineers, International Society for Research and Development, and Institute of Research Engineers and Doctors. He had visited nearly 22 countries in the world. Thank you, sir. I welcome you, sir.
Yeah, Murthy, thanks for the introduction, Murthy.
Thank you, sir. Thank you, sir.
Once again, on behalf of myself and on my own behalf, I thank the organizers for giving me this opportunity to share my views on my research work. And these research work which I am going to present it right now, you may have some chances that even you can have some focuses, and even you can choose some areas for your further research work, and there is much scope in this. In my project, and of course this is my PhD project which I done for my dissertation. So let me get into the presentation. Yeah. Murthy, is it visible, Pa? Murthy?
Yes, sir. Yes, sir. Visible, sir. Clearly visible, sir.
Yeah. Okay. So, topic of today's presentation, it is experimental studies on the suitability of industrial effluent for construction purposes. That is, for construction purposes, and we will be replacing the potable water with this industrial effluent. Let me give you the background of the problem. Mainly due to the water scarcity. Okay, water scarcity. It is mainly due to population explosion, urbanization, industrialization, etc. Population explosion means, I hope you know, our country, we are having an alarming situation that population is getting increased in the geometric progression, not even in the arithmetic progression. So water scarcity, there is much water scarcity due to this population explosion. Then due to urbanization means the rural area, it is getting urbanized, that is more cities were formed and more industries were coming. So to cater the needs of peoples, more urbanization were being done. So that is also a main reason for the water scarcity. The best example I can give you is Chennai. I hope many people are attending here from various states. Let me give you a few examples. Especially in the month of May, June, especially in the summer season, not only Chennai, many cities like even sometimes Mumbai, even sometimes Delhi, even sometimes Jaipur, capital of Rajasthan, all these places are having a lot of water scarcity problem, especially in the month of May, June, in the month of hot summer season. Then third issue, it is due to the industrialization. Yes, of course, this population explosion and industrialization, it should be proportional. If more population explosion is there and industrialization, obviously it has to be there, because without industrialization it is very difficult for the people to have their basic needs to be fulfilled. So industrialization, it should be there. If there are more number of industry, obviously more amount of water are required. Why? Because this whatever the industry they are constructing, whatever the industry they are planning, it needs some kind of construction. So this construction, it needs a lot of water, that too it needs pure water, that too it needs potable water. So many construction activity due to this population explosion, urbanization, industrialization. I hope this would be clear. If there is more population and if there is an urban, if we want to develop the cities, okay, obviously we have to have more number of construction. So the construction, it requires more amount of water. So what is the remedy? So we have to somehow we have to cater the water to all these people. So the only remedy it is we have to go for reuse of the water. So for reuse of water, I had considered various effluents, that is tannery effluent, textile effluent, then effluents from rice mills, then that is waste coming from rice mills, then the wastewater coming from milk industry, dairy industry, then the wastewater coming from food industry. Okay, all the wastewater I have tried, and in our area exclusively very near to my place, that is Erode and Perundarai, we are having more number of tannery and textile processing units. So it is easy for us to collect these effluents for doing our experimental research work. So I decided to collect the tannery and textile effluent from the nearly located SIPCOT. Those people who are residing, those people who know the geographical location of Erode, those people, they'll be knowing the position of the SIPCOT, which is very, very adjacent to our institute. So I decided in SIPCOT, there are more number of tannery and textile processing unit. So I decided, okay, let us take this effluent coming out of that treated, coming out of the industry and using it for construction. So this is the main reason I had chosen this tannery and textile effluent. Then what we did is we have to what I did is I compared whether any earlier works are carried out, any similar kind of this works are carried out for construction. Here what I did is, what my plan is, see, this tannery and textile effluent, no, I will take this, I will take both the company, they will be giving both the treated effluent as well as the non-treated effluent. So that effluent, I will replace this effluent for the potable water, because we will be in the construction activity, we will be using the potable water. So instead of this potable water, I will be using this replacing with the tannery and textile effluent. So the similar work, this Merchant et al., Omar et al., then Wu Yang Jung et al., this third person, he is an Chinese people who worked on wastewater taken from the municipality. Then Oliver Popwood, he also used the wastewater taken from this municipality. This Omar et al., Sarsiman et al., Al-Herti et al. Okay, these peoples which I have given in violet color, these peoples used the wastewater or waste coming from the refineries. These peoples belong to Saudi peoples. These peoples belong to Saudi peoples, and I hope you know in Saudi there are more number of refineries located. So what they did is they took the wastewater coming out of those refinery and they used it for construction, and they proved it to be successful one. So the same thing I also did here. Here, instead of using this potable water, I replaced the potable water with the tannery effluent and textile effluent. This is the background. This is the background I have chosen the tannery and textile effluent. Okay. So is my Murthy, is my presentation normal, or whether I am too fast or whether I am too slow?
Sir, normal, sir. Normal, sir.
Normal. Can I proceed further?
Yes, sir. Yes, sir. You can proceed, sir.
Okay. Somebody is telling voice is not audible.
Sometimes it will break, sir. Sometimes.
Yeah, few people they had told normal. Okay, I think
Yes, sir.
please. Okay, okay. Then I think I can proceed. For most
Okay,
of the
sir.
people, it is okay. Okay, this is the so far this is the process what I did before carrying out the experiments, and this following slide shows my methodology. Here what I did is I analyzed the characteristics of the untreated and treated tannery effluent, untreated and treated textile effluent. Here I had taken four components. Here I had taken four components. I hope this you can able to see. Um, Untreated and treated tannery effluent and untreated and treated textile effluent. Okay, so four components are there. Tannery effluent, two component, and textile effluent, two components are there. And I studied the properties of concrete such as both mechanical property as well as the durability property. Here, if you see this mechanical property, compressive strength, tensile strength, flexural, and the durability property, sulfate attack, chloride attack, corrosion. Then, apart from this, even I have studied a lot of other durability properties that it will be following. Then, now, when I am doing this research work, there was lot of problems I had faced because when these experiments, compressive strength, tensile strength, flexural strength, bond strength are carried out, mechanical property, absolutely there is no issue. But when coming to the durability property, all the sulfate attack, corrosion, chloride, everything, there are some issues. Okay, so that is the weights are totally reduced and the strength was very, very less. So to counteract, what I did is I used some I used some chemicals. I used some admixtures. Okay, I used some admixtures. Okay, then by after adding the admixtures, these are all the see. I think here I had given you all the properties what I have observed and studied. Sulfate attack, chloride attack, corrosion, chemical attack, alkali aggregate reaction, leachability of both chloride and sulfate, permeability, compressive strength, tensile strength, etc. All these things around 13 to 14 experiments I had carried out. And for your information, around 4,000 plus specimens I had cast and I had broken and I had tested. Okay, and I had inferred a lot of informations. So these are all the various tests. Then how where I collected all these effluents are, I mean, tannery and textile effluents. This first thing I collected the tannery effluent from the Meenakshi leathers, then SBMS leathers, Taj leathers, and I collected the textile effluent from Thai International, KPR Textile Processors, etc. So these are all the places where I collected the things. Then these are all the once again I had given it in the pictorial form. These are all the various tests I had carried out. So around 13 tests I had carried out. So selection of admixtures for selecting this particular area, it takes around for me around 6 to 9 months to just optimize, to just select the admixtures and to optimize the amount of the admixtures. So here if you see while seeing the properties, while studying the properties, mechanical property, absolutely there is no issue. But when come to this particular durability property, this permeability, sulfate attack, chloride attack, corrosion, all this plays a major role, and many loss of weight, and even the compressive strength it is reduced. Okay, and this corrosion of everything it has been I mean aggravated. So I selected the admixture and I optimized the admixture. And yeah, what I had told here, everything is given. No significant difference in the strength properties, absolutely, in compressive strength or flexural strength. But this second statement, admixtures were added to reduce the effect of concrete subjected to sulfate attack, chloride attack and corrosion. This even the acid attack, it has an it is also subjected to some effects. So various trials around for this. I had cast around 1,000 plus specimens, totally 4,000 plus specimens, and for this optimization comes around 1,000 plus specimens. So here, finally, based on various trials and errors, not single trial, around 40, 44 trials, I decided and chosen this. That is 5% fly ash with 2.5% concar, or with 2% calcium nitrate. Okay, and for tannery effluent. Here for textile effluent, it is 5% fly ash with 2% concar or 2% calcium nitrate. Okay, so these are all the things. Finally, I have selected as the admixtures and the correct, right proportion. And this, after deciding the thing, I decided to prolong the test up to 2.5 years at various intervals. Okay, 2.5 years at various intervals from 28 days, 60 days, 90 days, 180 days, 365 days, and 2 year, 2.5 years. 2 year and 2.5 years. See, here this is loss of weight of the concrete. This potable water. This at the 28 days. Due to sulfate attack is in the sodium sulfate solution. I immersed the concrete specimens, that is the cube, 15 centimeter by 15 centimeter cube, concrete cube. Then at the end of PW, it represents potable water. UTT, it represents untreated tannery effluent. TT, represents tannery effluent. UTTE, untreated textile effluent. TTE, treated textile effluent. I hope this should be clear. This nomenclature should be very clear. Once again, I repeat: PW, potable water. UTT, untreated tannery effluent. TT, treated tannery effluent. UTTE, untreated textile effluent. TTE, treated textile effluent. These are all the nomenclature. So here, if you see, I cast the concrete. I hope that basic things you know. In the concrete, instead of using the potable water, I replaced with the effluents. Okay, even I use the potable water also for the comparison. So, okay. Now, if you see at the end of 28 days, it is 0.48 for potable water. This is the standard thing, and this is our benchmark and reference which we have to compare further. So, potable water, it is the conventional concrete. Here, loss of weight, it is 0.48%. At the end of 180 days, it is 0.61. And at the end of 1 year, it is 0.72. And at the end of 2 years, it is 0.84. And at the end of At the end of 1 year, it is 0.72. At the end of 2 years, it is 0.84. At the end of 2.5 years, it is 0.93. So this is our standard one. This is our reference thing. Then you see, by using the untreated tannery effluent, the loss of weight, it is 4.81%. 188 days, 4.86. 1 year, 4.92. 2.5 year, 5.14. See, this is the loss of weight. It is adverse. This should be the loss of weight, but this is our actual loss of weight. Then coming to the tannery treated effluent, treated tannery effluent, it is 3.52 for 3.52% for 28 days, and for 2.5 years it is 3.99. And untreated textile effluent, it is 4.75 for 28 days, and it is 5.12 for 2.5 years. And for treated textile effluent, it is 3.46 for 28 days and 3.97% for 2.5 years. This is the loss of weight of concrete. Here I have to reduce this loss of weight to potable water. This, when I am adding the admixture, this result should be equally compared to this result. Then only our thing is right. Then this loss of weight when adding the admixture. See, the previous thing you can able to see 0.48. Let me take the highest one for 4.81 and 5.14. Just when I am adding the adding the admixtures. I am just adding the admixtures. Calcium nitrate. I mean this Concat 2.5 percentage and calcium nitrate 2 percentage. See, totally the maximum thing it is only 0.15. This is 0.16 means around 0.15. Okay, so if you see, so maximum it is 0.15. If you see in the previous slide, even for potable water it is 0.48. But when we add the admixture, it comes less than, the loss of weight is less than 0.115 or 0.16 percentage. So everything it has been neutralized. All the loss of weight due to this sulfate attack, it has been neutralized. Then coming to the next one, this is for this previous one. This is for tannery effluent, and this graph shows for the textile effluent. Here also, I think you can able to see just it is less than point. The previous one less than 0.16 percentage. This is less than 0.15 percentage. Just you see the table. For textile effluent, 4.75 and 3.97. Even this potable water, it is 0.58. But whereas for here, if you see the maximum itself, it is less than 0.15 percentage. So this is the effect. This reduction is due to the addition of this admixture, and this is for this is loss of weight. And here, pertaining to the compression tank, after testing the after testing the change in weight, I will be using the same specimen for this testing the compression tank. Here I had given it in the single graph. Okay, here if you see, I think let us take this as our benchmark. This sign, I think, okay, here. See, it is 24 or maximum 26 Newton per mm square, MPa, megapascal. Okay, it is nothing but 26 megapascal. But when we add the admixtures, see the compressive strength. So minimum, it is around 25. Maximum, it comes around 29. So by adding the admixture, the compressive strength it increased very high. Okay, this is particular for the treated and untreated tannery effluent. This graph shows for the textile effluent. Okay, here if you see the maximum, I think for this is our reference thing. So in the reference thing, it is less than the all the other thing by added with the admixture. So this is by as far as this compression strength is compression strength of concrete subjected to the sulfate attack is considered, it is totally neutralized. So this is mechanical property, and the previous thing I had shown it is the this is the loss of weight. This is the compression strength of the same specimen. So it is also increased. So this is for the above all these things. This is for the sulfate attack. For one sulfate attack, all these things are the results. Okay, now let us go to the chloride attack. Chloride attack, sodium chloride. I will be immersing the concrete cube in the 6% sodium chloride solution. After 28 days, I will take the cube and will wipe it off and dry it, and I'll be testing the thing. So for potable water, at the end of 28 days, it is 1.70. At the end of 2.5 years, it is 0.74. Similarly, you see the second thing, it is very dangerous, alarming, 7.91 and 6.8. Okay, so this is for tannery effluent. This is for textile effluent. Just you see the next results for when adding the admixtures. When adding the admixtures, the reduction in loss of weight is less than 0.35 percentage. Here, if you see, minimum, I think this we can take. In this table, that is 0.74 percentage is the lowest thing. 7.74 percentage is the lowest thing for 2.5 years. You just see the graph for tannery effluent, it is less than 0.35. It is less than 0.35, and even at the end of 2.5 years, it is even still reduced to 0.2 percentage. And this is particular for the tannery effluent. And if you take, this is for the textile effluent. For textile effluent, I think in the table it is textile effluent is 7.29, 7.29 and 3.38. So here textile effluent, it is less than 0.3, even it is less than the potable water. Okay, this is for the, as far as chloride attack is considered. After testing the loss of weight due to subjected to the chloride attack, the same specimen were tested for the compressive strength. So this is the compressive strength, and the compressive strength, it is this is our benchmark. This particular thing is our benchmark. So maximum it is around 26. Our minimum here it is 25, and when adding the admixtures, minimum 25 and maximum it shoots up to 29. Okay, so as far as this compressive strength of the concrete prepared by using tannery effluent, it is highly safe. Then this is for the textile effluent. Here also the strength it is getting increased due to the addition of the concurrent calcium nitrate. This is for the chloride attack. Now let us go for the corrosion of reinforcement bar embedded in the concrete. Here what we did is uh, we casted the uh, lollipop test. We used the lollipop test specimen for carrying out this corrosion. What we did is we take a cylinder diameter 15 centimeter and 30 centimeter, 15 centimeter diameter and 30 centimeter height, and inserted a 20 mm bar up to with a clear cover of 30 mm at the bottom. So we had given the cathode, we had given the we had passed the current, and we measured the current. At the end of 28 days, at the end of 28 days, what we did is we stopped the experiment. We removed we broken the cube, we broken the cylinder, we took the iron bar, and we know the weight, previous weight we know. Then after 28 days we tested the weight. In the first weight, see the difference. Without the addition of admixtures, it is around 10 percentage. Okay, even when we are using the potable water, since it is an induced corrosion, it is 6.2 percentage. Okay, it is 6.2 percentage. Okay, but when we add the admixtures, okay, when we add the admixtures, you just see the loss of weight, it is less than 3 percentage. Okay, so greatly it has been reduced by adding the admixture. The loss of weight is greatly reduced. This is a notable point. Then apart from this, we usually this is for this is for tannery effluent, and this is for textile effluent. Here also there is a loss of weight. Even when we add the admixture, it has been greatly reduced. Apart from this, I used Campachar coating. Okay, I just coated the that steel bar with the Campachar. So when steel bar is coated with Campachar, and along with the just without any admixtures, this is the result. It is less than 0.3. But with the height of admixture, the loss of weight, it is totally become negligible, or I cannot say negligible. It is less than 0.005 percentage. Just by coating this Campachar, total corrosion has been reduced. This is for a tannery effluent, and this graph shows the result for the textile effluent. Okay, this if we coat this Campachar, corrosion is totally reduced. Even I can say that even if you are not adding the admixtures, just if you coat this Campachar, even the weight will be less than 0.3 percentage. But only problem is in the after 3 years or after 5 years, this you will be having corrosion. That is the reason we are adding the admixtures. And this is for the chemical attack. This here I used the dilute sulfuric acid for 3% of 3% of diluted sulfuric acid. Then these are all the results. Here loss of weight is very high because it is immersed in the acid solution for 28 days. So initially it is without adding the admixture, 3.5 percentage reduced. Okay, lowest it is around 3 percentage. But when we add the admixtures, it's totally reduced to 2 percentage. What you have to see is you have to observe that even by using the potable water, you'll be having the same kind of adverse effect. Okay, this you have to take into account. Then this is for this one is for tannery effluent, and this one is for textile effluent. Then coming to the compressive strength, okay, that particular cubes we had checked for loss of weight of attack, acid attack. No, that I had subjected to the compressive strength. You can able to see initially even for our potable water it is around uh, 18 Newton or 19 MPa. When we add the admixtures, it's little bit the compressive strength is increased and loss of weight it is decreased. And this is for tannery effluent and this is for textile effluent. So as far as this acid attack is considered, so our achievable, our required strength we had obtained that is at par with the potable water. Then alkali aggregate reaction, this is nothing but the expansion. So expansion, there is no much difference. Okay, even without adding admixture or by adding the admixture, there is no much difference. That is the reason I cannot given you the comparison. This is without the admixture. This is for tannery effluent and this is for textile effluent. Then leachability. Leachability, it's a very important environment parameter. So this when we used to construct the building, when the buildings is subjected to any rainfall, that rain it will fall on the building and the water it will be getting into the soil. So it may affect the soil property. So for that I carried out this leachability property. Here also without adding admixtures, it is around 200 milligram per liter. But admixtures are added, it is almost reduced to 180 milligram per liter. And here one more point we have to observe is when the days got increased, this particular leachability is getting reduced. And if we continued for 3 years, 4 years, 5 years, at one point of time, we will be having a minimal leachability of 140 milligram per liter. This is for sulfate attack for concrete tannery effluent. This is for textile effluent. This is for the concrete constructed by using the textile effluent. So here also textile effluent also, it is when we add the admixture, it is less than 180 megapascal. 180 milligram per liter. Here also it is getting reduced when the age passes. Then this is leachability of chloride from the concrete. This is for tannery effluent. This is for textile effluent. Both the sulfate, leachability for sulfate also I have determined. Leachability of the chloride also I have determined. Then comes the next durability property, it is the permeability. So permeability, I hope you know, it is the passing the water through the concrete and what is the time taken, etc. We will be studying. And if you see the permeability, one encouraging factor is when the years increases, the permeability is getting decreased. So here also it is good. As far this is for the tannery effluent, when we add the admixtures, there is no much difference. When we add the admixtures, there is no much difference. Okay, as we had seen a significant difference in compressive strength or loss of weight due to corrosion. Here there is no significant effect. So this is for textile effluent and previous one this is for tannery effluent. Here also almost the same property it is being observed. Then coming to the so far I have discussed about all the durability properties. Now I am going to discuss about the mechanical properties. Mechanical properties I used the universal testing machine. I casted the 15 centimeter tube and I subjected to various loads I broke and I proceeded further. So this is the compressive strength. So minimum it is 24 Newton per mm square. The grade of concrete what I choose is only 20 grade of concrete, so no problem. So here minimum it is 24 and maximum it is bumping up to 26. When we add the admixtures, even it is more than 28. So this is an encouraging factor as far as the compressive strength of concrete is determined. This is for tannery effluent. The next slide it shows the comparison for the textile effluent. Here also there is no much issues. So as far as compressive strength, that is the durability property is considered, it is good. Then let me go to the tensile strength. So once if compressive strength is good, obviously we'll be having the good tensile strength. But anyhow, I could not take for chance, so I determined by using the specimens. So here no much variation. The minimum it is 2.2 Newton per mm square, but then goes to 2.7 Newton per mm square. Even with the addition of admixtures, it is not much variable. This three shows this three line shows the tensile strength without admixture at various ages. Here, if you see, this shows the with the addition of admixture. These are all the trend patterns. Then coming to this is for tannery effluent and this is for textile effluent. So in textile effluent, by using the textile effluent for concrete, there is no much adverse effect. Then coming to the flexural strength I casted 100 centimeter, 100 centimeter bar with the 10 centimeter by 10 centimeter. Then without using any without using any RCC, I just used the PCC, and this is the flexural strength. Here I had used the admixture, but there is no adverse effect, and so I have not given you the comparison. Just you can see these three things. It's a minimum 3.5 flexural strength and maximum it is 3 plus that. It is 3.8 MPa. This is for tannery effluent and this is for textile effluent. So the flexural strength it is very very good. There is no much issue in this flexural strength. All the three strengths, compressive, tensile, flexural, no problems. Then this is a failure load of the RCC beam. This I had a cast on 1 meter beam with the reinforcements. So here I see when it is going to when there is a break in this concrete beam. So from 31 to maximum it is 34. 34 kilonewton. So it is as far as the failure load of RCC beam, it is highly safe. This is for tannery effluent, and the next one it is for textile effluent. Then comes the bond strength of our concrete. Bond strength, I hope you know, we will be inserting a rod in the concrete tube and we will be pulling out and we will be determining the strength. So here bonding strength I received minimum 1.4 Newton per mm square and the maximum is 1.7 Newton per mm square. And this is our benchmark thing. So benchmark it is around 1.7. So almost all the other, even with the addition of admixtures, there is no much effect. Okay, so varies from 1.4 to 1.7. So it's a good sign as far as this bond strength of the concrete is good. As far as the tannery effluent is considered, then then here what I did is two experiments I carried out. I once again induced the corrosion in the pull-out test. Then when we induce the corrosion, now the strength it is, bond strength it is decreased, and when we add the admixtures, it is little bit increased. So here minimum reference point is PW, it is around 0.6 MPa, but when we add the admixtures, it is 0.9 to maximum 1.1 MPa. So this is the bond strength of the concrete for specimen prepared by using the textile effluent. The previous one for tannery effluent, this is for textile effluent. So almost the same behavior pattern it is observed for the textile effluent as far as this bond strength of the concrete is concerned, which is subjected to concrete which is prepared by using the textile effluent. So both are almost the same. I think I can show you the comparison just to see. So this is around 1.7. Here also it is around 1.7. No much variation. Then I induce the corrosion. When I induce the corrosion, the bond strength when adding the admixture it is a little bit increased, but without admixtures it is 0.5 kilonewton. So these are all the various experiments I have conducted to carry out to prove that the tannery and textile effluent can be used for construction activity. Only thing is the drawback which I faced, it is availability of the water, because the government is imposing lot of restriction to take the water and use it in construction. But now I think in the forthcoming days, when there is acute shortage of water, this is the one and only solution which an government can find to counteract these effects. And as far as the cost benefit ratio is concerned, initial investment it is high because addition of admixtures, we have to transport the water. But when there is no water, there is no alternative. We have to go for this project, as we are now replacing the river sand with the help of the manufacturing sand and plastering sand. So this is in the forthcoming days, this may be a boom to the people's in as far as the water consumption or water conservation or water management is to be taken into consideration. So let me conclude the thing. So I can conclude, it is concluded that the tannery and textile effluent can be used for construction purpose by adding 5%. This is the bottom line. You have to take this message. 5% fly ash with 2.5% concrete or 2% calcium nitrate along with the concrete prepared by using tannery effluents. And 5%, this is for tannery effluent, and this one for textile effluent is 5% fly ash with the 2% concrete or 2% nitrate, calcium nitrate. So this is our basic finding, and by using the thing we can easily counteract various adverse effects, and we can use the tannery and textile effluent for construction purposes. And these are all the few references thing. Okay, so with this, let me stop my presentation and let us see. Yeah. That's my end of the presentation. If you're having any doubt, you can ask me. Feel free to ask any doubts, Paul. Okay.
Yes, sir. For participants, if you have any questions, kindly unmute the mic and ask.
Feel free to ask the questions. Yeah, thank you. Can you explain the sampling procedure? Sampling procedure to take samples. Sendil Kumar sir, what samples? Please unmute yourself. Sendil Kumar sir, please come online. Unmute yourself. I couldn't able to get your questions. Sendil Kumar sir.
Effluent வாட்டர்னு போஸ்ட் பண்ணிருக்காங்க சார்.
புரியலீங்களே, அவர் என்ன சொல்ல வராருன்னு புரியலையே, என்ன கேக்குறாருன்னு. சார் ப்ளீஸ் லைன்ல வாங்க.
செந்தில்குமார் சார், சார் அன்மியூட் பண்ணி கேளுங்க சார்.
ஹலோ
சார் சொல்லுங்க
சார். இப்போ சாம்பிளிங் எடுக்கிறீங்களா சார்? வாட்டர் சாம்பிள் எடுக்கிறீங்களா?
சொல்லுங்க.
அந்த சாம்பிளை எப்படி எடுக்கணும் அப்படின்றத கேட்டுங்க.
ஓகேங்க, that is very easy. நம்ம வந்து just we have to take the can, okay, and there will be two outlets. One outlet, if you see that outlet, it is the treated water will be coming out, and in the another outlet untreated water will be coming out. So if we can take the can and we can keep it at that place, we have to get the prior permission and we have to take the sample. Just as we are collecting in bucket of water, we'll be collecting the samples. Instead of bucket, we'll be using the can. Is your question answered or வேற ஏதாவது கேக்குறீங்களா?
லேக்லாம் போய் எடுக்கிறோம்ல சார் சாம்பிளிங்?
Little bit louder.
லேக் ஆர் ரிவர்லாம் எடுக்கிறோம்ல சார், அதே மாதிரி தான் சாம்பிளிங்கா இங்கேயும்?
Same. Just same. Only you have to get the permission.
Okay. Thank you.
Okay.
Sir, one more question வந்திருக்குங்க சார் chat boxல.
ஆமாங்க பாத்தங்க, ஏதோ பத்தலி ஷிலா. Using water in concrete, is there any delay in early strength of concrete compared to no. This answer for Shila, there is no no delay in early strength of the concrete. As far as the strength property, as far as the mechanical property is concerned, there is no issue. And the next one, Muthulakshmi, can you explain how you have experimented the permeability test with the sample? What is okay? Muthulakshmi madam, actually the same procedure as we did it in our concrete lab, that permeability. We will take the concrete specimen, that is concrete cube of size 15 centimeter by 15 centimeter by 15 centimeter, and we will be keeping it in the permeability apparatus, permeability mode, and on one side we will be plunging the water into the equipment. On the other side, the water draining, that is the water that is coming out of this particular sample. Okay, that we will be collecting, and we are having formula by applying the formula and the data, we will be getting the permeability. Is is your question answered, madam? Mudalash madam, is your question answered?
Yes, sir. Ma'am told yes.
Okay, sir. Any changes in workability of concrete? Any changes in? No. Absolute, Sudarshan. Absolutely no changes in the workability of concrete when we add the effluent. Workability, there is no pertaining any issue due to this workability. Any other questions?
Sir, ma'am, if you have any questions, kindly ask. So, यार question केक sir.
There is some question. Did you find any other durability problem which you
Yes, sir.
have
No only.
expected? Yeah, durability, it is full of problem. All the issues we had faced in the durability properties like chloride attack, sulfate attack, corrosion, full of issues. And to overcome these issues, we had a many trial and error method to select and optimize the admixtures. That is a very big tough challenge. Around 1,000 plus samples has been cast, and the results have been this optimization of admixtures are done. Is my questions answered? Next question, admixture used only for durability property. Yeah, absolutely. If you see, I think from the test properties, it is keen that sulfate attack, chloride attack, corrosion, and corrosion and bonding strength, as far and permeability. Let us leave permeability. So sulfate, chloride attack, acid attack, and corrosion. This admixture plays major role only in the durability property, and I can say only a little role is played by the admixture for the mechanical property. Very mere little role, not a good role as far as this durability property. Up to maximum, which exposure condition we can use this concrete? Yeah. This is a good question. This even for severe conditions we can use, because we are using the admixtures. Even if we use for the coastal environment or marine environment, even this admixture we are using, this will up to some extent it will counteract the adverse effect due to coastal environment. Even that is a good one. Even for coastal environment we can use this concrete. Without Rajeshwari Mani, sir, without treatment or partial treated effluent adding to concrete mix, what kind of problems? Yeah, this will be having all kind of durability problems. Spalling may occur within the construction, of the building with the help of untreated treated effluent. Spalling may occur. Even sometimes leaching may occur. Even sometimes many cracks may be formed. A lot of problems will be occurring. For that reason only, I had shown how to shown the selection and optimization of the admixtures. No, that is the reason we are selecting and optimizing the admixture, and we are adding the admixture to the concrete. Still, I can answer you. If you are having a fever, okay, if you are having fever, we are taking the tablet. No, it is almost like this. If there is any problem, or if you are anticipating some problem, we have to add in addition, in preventive measures, we have to add the admixtures. How to rectify that? I already used in that count. It is only rehabilitation you have to do. If you already used in the concrete, you have to go for only the rehabilitation or retrofitting method you have to do. No other ways. Can you highlight some of the durability tests, which is very much, yeah, you can make a note of it. Sulfate attack, chloride attack, then acid attack, then corrosion. Now we are having SEM analysis, then bond strength corrosion, leachability, permeability. All this thing you can do it for durability tests. Adolf Marvel sir, it will make any difference if you use municipal effluents? Yeah, you have to go. You have to study the properties of the municipal effluent, and they based on the properties. You have to see the sulfate content, you have to see the chloride content, and you have to see the TDS, total dissolved solids. All this, after seeing this contents only, you have to decide whether to use the municipal effluent or not. And moreover, if you are using the municipal effluent, you have to be, I think there is some kind of permission you have to get it from the government. Government said you have to get some permission. Yeah. Any other questions? SEM analysis reports, how far we can interpret. Yeah, this for interpreting the SEM analysis, I think only in IA, everywhere we can get the SEM analysis result. But to have the interpretation, you have to have some experts. Those experts are available only in ECRC and IIT. Here you can get the result from either PhD Tech or from Karan University or from Shastra, you can get the results. But for inferring the results, for analyzing, you have to get the help from the experts in IITs and SCRC. Thank you. Any other questions? Yeah, Sudarshan. Yes, I did corrosion test where steel is sulfide. Because in RCC where steel is sulfide due to. Sir, have you did any corrosion test? Yeah, Sudarshan, I did the corrosion test. Even I had showed you the results. No, even I had quoted I used the admixtures. Apart from using the admixture, I quoted with the Kempact chart. Do you remember, Pa? I think in 30th slide or 35th slide, let me show you. Just wait, I'll show you the presentation.
Participants, if you have any questions, you can ask once again.
Sudarshan, here is the answer for your questions. Here we have used the, I think the corrosion we have studied, and when we use the admixtures, this is the reduction loss of it. When I quoted with temperature, you can able to see the result. Excellent result has been observed. Any other questions? Sir, is there any alteration needed in nominal cover value? No. 30 mm. 30 mm is more than sufficient. Normal cover 30 mm is more than sufficient. Any other questions, please?
Shall we wind up, sir?
Yeah, once again, let me thank you, the organizers, for giving me this wonderful opportunity to share my research work. I think after a very long time, I am sharing this research work. And thank you for your opportunity. And one more question is, no. This question I had answered. Okay. Anyhow, I thank the organizers for giving me this wonderful opportunity. Thank you.
Now we call Gayatri ma'am to give vote of thanks.
Thank you, sir, for your valuable time and for sharing our most wonderful and knowledgeable session. Thank you once again, sir. And I thank all the participants for active participation in all these 5 days faculty development program. And I thank our management, principal and HOD ma'am for giving us this opportunity to organize this program. And once again, thank you, Nirmal sir, for sharing your knowledge.
Thank you, madam. Thank you, madam.
Thank you, sir.
Thank you, sir.